Assalamualaikum, my name is Fatiah. So today I will be presenting about water and mineral uptake. So there's two main way for water and mineral to enter the root. So there's in the figure show that there's two pathway, which is pathway A and pathway B. So in pathway A, the water weaves its way between the cells, means that it diffuses from porous cells of one cell to cell wall of adjacent cells. Here, it was brought by the Casparian strip. Casparian strip is the waxy layer that surrounds the endodermal cell, thus force water to enter the endodermal cells through plasma membrane. Although in pathway B, the water travels from plasma membrane of one cell to another plasma membrane of another cells, and it was connected by opening called plasmodesmata. Regardless of the pathway, the water enters the root cells when osmotic pressure in the root tissue is lower than the soil solution. So if more water outside of the root and less water inside the root, the water will move by osmosis, causing this osmotic pressure. Move along to our next slide, which is mineral uptake. Mineral uptake is contrast to the passive movement of water. Mineral can be taken up by passive and active transport. Here, the Casparian strip function differ from the water uptake. The Casparian strip prevents the backflow of minerals and allow plants to maintain a higher mineral concentration in root xylem. Okay. By what mechanism do minerals cross plasma membrane? The energy ATP is used, but only indirectly. Ion cannot cross the plasma membrane because they are unable to enter in the non-polar portion of the lipid bilayer. Plant cells expend energy to actively take up and concentrate mineral ion. So as shown in figure 25.7b, the plasma membrane pump called proton pump hydrolyze ATP and use the energy released to transport hydrogen ion H+ out of the cell. An electrochemical gradient that drives positively charged ions such as K+ through the channel protein into the cell. Negatively charged minerals ions such as NO2- are transported along with H+ by carrier proteins. Although H+ does not need or not require any energy because it moves along the gradients. These models are based on chemiosmosis. Chemiosmosis is the establishment of an electrochemical gradient to perform work. Okay, next is adaptation of root for mineral uptake. Two mutualistic relationships assist root in obtaining mineral nutrients. Root nodules involve a mutualistic relationship with bacteria, and mycorrhizae are a mutualistic relationship with fungi. Bacterial nitrogen fixation is responsible for most of the conversion of nitrogen from air into becoming ammonia. So the most common type of symbiosis is rhizobia. Nitrogen fixation an energy-intensive process. So there's a special condition for it, and the first and foremost is an anaerobic environment. This is due to the presence of oxygen disrupts the nitrogen fixing process. Thus, these bacteria live inside the root nodules. Because in root nodules, the oxygen are maintained high enough to continue the cellular respiration, but low enough as to not to inactive important nitrogen fixing enzyme. The second type of mutualistic relationship called mycorrhizae, which is involve fungi and almost all plant roots. The fungus increase the surface area for water and mineral uptake, and also break down organic matter in the soil. So the releasing nutrients, it releases nutrients that for the plant can use. In return, the root furnishes the fungus with sugar and amino acids. Other than that, there's a parasitic plants and carnivorous plants. Parasitic plants take a nutrient from another plant, but carnivorous plants such as the Venus flytrap obtain some nitrogen and minerals when their leaf capture and digest insect. So that's all for presentation today from me. So thank you.